B, which contains infinitely many elements, can you pick each element and check whether it is image and whether it is image, whether it is image? You are not able to, right, make a verification of this kind, where you are watching each and every member and examining whether it is an image or not. But how we are going to do it? When the set is infinite, A is an infinite set, suppose B is also an infinite set. B is an infinite set. There are infinitely many elements. We have to check that each element here is an image. So when there is an infinite collection, right? Take an arbitrary member here. Why? Take an arbitrary member of second set. Arbitrary member. Arbitrary any member. Randomly chosen. Suppose after we give a lecture for 1 hour, we wanted to find whether students have understood. Right? Whether teachers are going to ask each and every student one question and check whether he has understood. No. At random, we pick one student from here, one student from there, and ask some questions. If 1 or 2 students are able to answer the question, we assume that the entire class has understood. Fine? You take an arbitrary member of B. Arbitrary, randomly chosen member, randomly picked member. Find whether it has a pre-image. If pre-image untada check mark. For any y, want to prove on each statement noted. Please look at this statement. I am going to ask you after you come back here for offline class. Okay. In order to prove that f is onto, right? This verification is required for you. For any y belongs to codomain with B and the codomain. For any y belongs to the codomain, right? We must show that there exists the symbol you know, there exists some member x belongs to domain. The B and the very good. B and the very, the A and the domain. There exists some element x in the domain such that f of x is equal to y. F of x is equal to y, remember? Y is the image of x. Y happens to be image. Y happens to be the image. Right? You are qualifying y to be the image, where y is a randomly chosen element. Y is an arbitrary element. For an arbitrary element y, if you are able to show that there exists some x belongs to R, whose image is y, f of x is equal to y. Since y is arbitrary, it could be first member, or second member, or third member, or any member. Okay, arbitrary. When you are applying result for an arbitrary member, it applies for every member. That is the method we are using in mathematics while proving any result where infinitely many members are involved. Take an arbitrary member. For example, just look at this. I will take a parallel example very quickly. You take one set A, other set B. Right? How do you know how to prove that A is a subset of B? How to prove that A is a subset of B? Assume that A is infinite, B is also infinite. How do you prove that A is a subset of B? Are you going to check whether infinitely many members of A are contained here by examining each and every element? It's not possible. It's impossible. It's impossible to check whether infinitely many elements of A are contained in B by examining every member, right, of the set. It's not possible. In order to prove that all the elements of A are contained in B, in order to prove that A is a subset of B, take an arbitrary member of A. Let x be any member of A. Any of them arbitrary. Let x be an arbitrary member of A. If an arbitrary member of A, suppose it belongs to B also, for x belongs to A, if x is arbitrary, if x belongs to B also, right? So here there is a box labeled as A, here there is a box labeled as B. We want to know whether every member of A is contained in B. What you are going to do? Take a arbitrary member of the first set. show that this member X also belongs to B. If this arbitrary member first set belongs to B, second set also. Since X is arbitrary, we conclude that every member of the first set is contained in the other set. Right? This is how we prove that one set is included in the other set. The set inclusion relation. So on to check ಮಾಡಿ ಅಷ್ಟೇ. ಜನರಲ್ ಆಗಿ ಮ್ಯಾಥಮೆಟಿಕಲ್ ಥಿಯರಮ್ಸ್ ಪ್ರೂವ್ ಮಾಡುವಾಗೆಲ್ಲ ಆನ್ ಟು ದಿಸ್ ಚೆಕ್ ಮಾಡಿಗೆ take a random arbitrarily chosen element of the codomain. For any y belongs to B, show that there exists some x belongs to A, for which f of x equal to y, proving that y is an image and mapping is onto. Onto is surjective mapping. 1 andre injective mapping, onto is surjective mapping. So I am going to conclude this today's session by asking you one question. What is I am just writing two relations here. One is this. You are studying reflexive, symmetry, transitive, etc. Different types of relations. Okay. One is this relation. I am not going to read it. You have to read by yourself. What is it? Other relation is this. Fine. What is the difference between these two relations? Why they are meant for? Right? How do you read the first one? How do you read the second one? Right? Why these two relations are meant for? What is the difference between two relations? Right? One is this, other one is this. Okay. So this is a question you have to answer. I will take a break here. We will discuss some continuity and differentiability aspects in the next video, in the next session, in the video lessons. Fine. And thereafter we will enter the syllabus. Okay. Maybe on Friday we will enter into the syllabus. This Friday, right? We will start the syllabus topics. So just go through this and also answer this question. What is the difference between two relations here? Why they are meant for? Right? When you are using them.